Hey everyone, welcome back to our SQL tutorial series. In the last episode, we covered the core constraints, not null, unique, primary key, and foreign key. Today, let's look at two more essential constraints that help us keep our data accurate and practical. Check, default. Check is to validate input values, default to automatically fill in missing values. We will also learn about a key concept behind all this, data integrity, and how these constraints keep your database trustworthy. Let's get started. The check constraint is used to limit the range of values for a column. Imagine you are creating an employee table. It makes no sense to have someone under 18 as an employee. Here's how you can enforce that rule. Let me create an employees table. Here I will add check for age. That is, check age is greater than or equal to 18. Let's execute. So the table has been created. Now let's try and insert some data into this table. Here for the age I will add 25 and let's execute. So the data has been inserted successfully. So now let me change the value of age to something else, that is less than 18. We'll add 7 and we'll change the employee ID to 2, name to let's say Ria, and let's execute. So the insert statement is conflicted with the checks constraint. The conflict occurred in database training. Table DBO employees column age. That means we cannot insert the age value less than or equal to 18. It should be always greater than or equal to 18. Some of the use case of check constraints are ensuring age is positive, salary is above minimum wage, quantity ordered is not negative, status is one of certain allowed values. Think of check like a guard at a club entrance. Only people meeting certain conditions are allowed in. The default constraint automatically fills in a value when no value is provided. Let's say you are tracking product inventory. If no stock is specified, you might want to assume it starts at 100. Let me create a products table. So in the stock, we have defined the int and here we'll say default 100. So let's execute this. Let's execute this. Table has been created. Now we'll try to insert some data. So here I have chosen only product ID and name but not the stock. Let me execute. So one row has been affected. We'll see what are the data insert. Select this and execute. As you can see, the stock has been updated to 100 by default even though we have not mentioned. So let me insert another data 102 product ID and say desktop. And here I will specify stock as 85 and here also I will say stock. Let me execute this. So one row has been affected and 85 is the stock. So if you don't insert a product without a stock, it will take always 100 as a default. It's like placing an order online and the site pre-selects the default quantity as 1 unless you change it. Use default for auto setting status to active, timestamps like created at, country defaults like India for local apps. Now let's step back and look at the bigger picture. Data integrity is all about ensuring your data remains accurate, consistent, and trustworthy. There are three main types of data integrity in SQL. 1. Entity integrity. 2. Referential integrity. Domain integrity. 1. Entity integrity. It is enforced using primary key. Every row must be unique and identifiable. No duplicate or null IDs are allowed. For example, every person has a unique passport number. 2. Referential integrity. Enforced using foreign key. Make sure relationship between tables are valid. Example, an order must reference represents a real customer. An invoice must be tied to an existing customer. Next is domain integrity. Enforced using not null, check, default, unique. Ensure data is valid within its domain. Example, age must be greater than or equal to 18, emails must be unique. All constraints you have learned help enforce these three integrity types, and that's how modern databases stay clean and reliable. Let's quickly recap everything you learned today. Check. Validates that data meets certain rules. Default fills in values automatically if not provided. Data integrity, we have entity integrity for unique rows, referential integrity for valid relationships, domain integrity for valid values. Always use check for condition that makes logical sense. Use default to reduce errors and save effort during inserts. Don't over restrict. Too many constraints can make inserts difficult. Document constraints clearly for your team. And that's wrap up this video on check, default and data integrity in SQL. Constraints are not just rules. They are guardrails that protect your database from chaos and mistakes. If you like this video, hit that like button and subscribe for more such tutorials. Thanks for watching, and as always, happy querying.